Here's a question for you. How many streaming services do you subscribe to every year? I've got Netflix, Disney+, Spotify, and Amazon Prime. Okay, another question. How much toothpaste do you use in a year? If the price of streaming services tripled, how would that affect how many streaming services you're willing to subscribe to in a year? What about if the price of toothpaste tripled? How would that affect how much toothpaste you buy in a year? Does the tripling of the price of these two different products affect your willingness to buy them in the same way? Possibly not. The law of demand says that if price increases, people are going to buy less of that product. But how much less? This is what the super important idea of price elasticity of demand looks at. I'm Mr. Racine. Welcome to today's episode of
Economics videos that don't suck.
Legal disclaimer. Price elasticity of demand measures the sensitivity of quantity demanded to changes in price. If we raise the price of a product, is the quantity demanded of that product going to fall by a relatively large amount or by not so much? To represent the concept of price elasticity of demand, we calculate a number which we call the price elasticity of demand coefficient, though often you'll see this just abbreviated as PED. PED equals the absolute value of the percentage change in quantity demanded divided by the percentage change in price. So we focus on two things: the percentage change in price and the resulting percentage change in quantity demanded. Why do we focus on the percentage change in price and quantity and not just the total change in price in dollars and the total change in quantity just in units that people will buy? Well, consider two different products, product A and product B. The price of product A is $1 and quantity demanded for product A is 1,000 units. Product B costs $10,000 and everyday quantity demanded is just 2. Now, assume that the price of product A increases by $1, so it now costs $2. And as a result, quantity demanded now falls all the way to $999. At the same time, product B's price also increases by $1 to $10,001, and as a result, quantity demanded falls to only 1. For both products, the price has increased by $1 and the quantity demanded has fallen by 1 unit. But can we say that both of these products are equally sensitive to changes in price? Definitely not, no, right? Product A's price doubled, but only 1/1000th of all of the people who were originally buying the product decided that that price increase was enough to get them to stop buying the product. Product B's price increased by 1/100th of 1%, and they lost half of their customers as a result. Clearly, the consumers in the market for product B are much more sensitive to changes in price than the consumers in the market for product A. So this is why it's important that we focus on the percentage change and not just the change in pure dollars and unit value. So let's examine a product that faces what we're going to call inelastic demand. Consider the demand for coffee in a hypothetical town, Caffeinburg. When the price of coffee was $1, quantity demanded of coffee was 100 cups of coffee a day. Let's assume that the price of coffee then increases to $1.50, and as a result of that price increase, quantity demanded falls to 90. In order to calculate the price elasticity of demand coefficient for coffee in Caffeinburg, we need to first figure out what is the percentage change in price and what is the percentage change in quantity. On AP exams and in most other situations, you can calculate percentage change as follows: the new value minus the original value divided by the original value. This will then give you a decimal, and in order to get it into percentage form, we then multiply that number by 100. So in our example, the price of coffee went from $1 to $1.50. We can plug these numbers in to calculate the percentage change in price. $1.50, the new value, minus $1, the original value, divided by $1, all times 100. We can do some arithmetic kung fu, and we get 50%. There has been a 50% increase in the price of coffee. We can make the same calculation to get the percentage change in quantity. Quantity fell from 100 cups of coffee to 90 cups of coffee. So percentage change in quantity demanded of coffee would be calculated as 90, the new quantity of coffee demanded, minus 100, the original quantity, divided by 100, all times 100. Again, algebra kung fu. Hoo-yah! Hoo-yah! And we get minus 10%. The price of coffee has decreased by 10%, and notice a decrease in price results in a negative percentage change. So we now have the percentage change in price, the percentage change in quantity. We can plug these numbers into our PED calculation. Percentage change in quantity demanded is negative 10%, and percentage change in price is plus 50%. The percentages cancel out, and we get negative 10 over 50, or negative 1 over 5, which is equal to negative 0.2. But remember, we take the absolute value of this number, so we're left with 0.2. 0.2, the number that we have calculated as price elasticity of demand coefficient for coffee, is less than 1. When the PED coefficient is less than 1, we say that demand is inelastic. But what does that actually mean? Okay, look, if this number is less than 1, then we know for sure that the top is smaller than the bottom. Remember your fractions, right? If the top is bigger than the bottom, then it's an improper fraction, right? And that thing is greater than 1. So if PED is less than 1, then that means, by definition, the top of this fraction is smaller than the bottom. Or the percentage change in quantity is smaller than the percentage change in price. What are we saying? A change in price leads to a relatively smaller change in quantity demanded. Quantity demanded of the product is relatively insensitive to changes in price. In the case of our coffee example, the price increased by 50%, but quantity demanded fell by less than 50%. In this case, only 10%. Demand for coffee is inelastic. Quantity demanded of coffee is relatively insensitive to changes in price. When price goes up, quantity demanded is going to fall, but by a relatively smaller amount. And if price goes down, quantity demanded will rise, but again, by a relatively smaller amount. Let's consider the alternative. Okay, consider the market for salmon steaks. When the price of salmon steaks was $10, quantity demanded was $50. The price of salmon steaks increased to $12 a piece, and quantity demanded fell to $25. Okay, use this data and you calculate the price elasticity of demand coefficient. No, seriously, pause the video, go and calculate it, and then come back and I'll do it and you can check your work. I'll wait. Okay, here's how I got it, and you can check against your work if you actually did it. Price increased from $10 to $12. That would be calculated as $12 minus $10 divided by 10 times 100, or an increase in price of 20. And quantity demanded decreased from 50 to 25, so we would calculate this as 25 minus 50 divided by 50 times 100, or a 50% decrease in quantity demanded. We can then plug those numbers in to our price elasticity of demand coefficient, the absolute value of negative 50% divided by 20%, which gives us 2.5. Price elasticity of demand coefficient for salmon is 2.5. 2.5 is greater than 1. When the price elasticity of demand coefficient is greater than 1, we say that demand is elastic. What does that mean? Again, if the price elasticity of demand coefficient is greater than 1, then that means that the top of this thing must be bigger than the bottom. percentage change in quantity demanded must be bigger than the percentage change in price. A change in price leads to a larger change in quantity demanded. This is what we call elastic demand. When demand for a product is elastic, quantity demanded is relatively sensitive to changes in price. In the case of salmon steak, price increased by 20% and quantity demanded decreased by more than 20%, in this case 50%. Similarly, we understand if demand is elastic, if price decreases by a certain percentage, quantity demanded should increase by an even larger percentage. Okay, we have three other relatively unique cases that are marginally interesting and you may be tested on. What if the price of a product increases by 10% and quantity demanded decreases by exactly 10%? Well, our PET calculation would be minus 10% divided by 10%. Take the absolute value, you would get 1. When PED equals 1, we say that demand for the good is unit elastic or unitary elastic. Unitary elasticity of demand suggests that an increase in price will lead to an exact same percentage size decrease in quantity demanded, or a decrease in price will result in quantity demanded increasing by the same percentage. What if price for a product increases by 50% and quantity demanded doesn't change at all? It stays the exact same. There's a 0% change in quantity demanded. In this case, PED would be calculated as 0% divided by 50%, or 0. When PED is equal to 0, we say that demand is perfectly inelastic. And what this means is consumers will never change the quantity they demanded, regardless of the price. They're always going to buy the exact same quantity. A perfectly inelastic demand curve would look like this. If this is the price, this is the quantity demanded. If price goes up, quantity demanded is the same. Price goes down, quantity demanded is the same. What if we have a product where we increase price by an infinitesimally small amount, and as a result, quantity demanded decreases to 0 right away? In this situation, we say that price elasticity of demand is equal to infinity, and we call this perfectly elastic demand. The demand curve would look like this. And it suggests that consumers will buy any quantity at all, but you have to charge this one price. If you raise the price by even 1/100th of a penny, all of a sudden nobody's going to buy anything. We'll come back to this when we consider how firms view the market in perfectly competitive markets. If you forget which one of these demand curves is the perfectly inelastic one and which one is the perfectly elastic one, this one looks like an I for inelastic, and this one could be the start of the E for elastic. It's dumb, but hopefully it will help you remember it. Okay, so this has been price elasticity of demand, its calculation and interpretation. Price elasticity of demand measures the sensitivity of quantity demanded to changes in price. We calculate the price elasticity of demand coefficient as the absolute value of the percentage change in quantity demanded divided by the percentage change in price. If the price elasticity of demand coefficient is greater than 1, we say that demand is elastic. This means that a change in price leads to a relatively larger change in quantity demanded. Quantity demanded is relatively sensitive to changes in price. If PED is less than 1, we call this relatively inelastic demand. This suggests that a change in price will lead to a relatively smaller change in quantity demanded. Quantity demanded is relatively insensitive to changes in price. PED could be somehow exactly equal to 1, in which case we call this unit elastic demand or unitary elastic demand. An increase in price of a certain percentage will lead to the exact same size decrease in quantity demanded percentage-wise, and a decrease in price would lead to quantity demanded increasing by the same relative amount. If PED is equal to 0, we call this perfectly inelastic demand. It means that quantity demanded will never change regardless of the price. And finally, when PED is equal to infinity, we call this perfectly elastic demand, which suggests that at one given price, consumers would buy any quantity that producers could provide, but if you raise the price by even 1 penny, quantity demanded will fall to 0. Okay, next video we'll consider why do some goods face more elastic demand and why do other goods face more inelastic demand, and we'll also look at how does facing inelastic or elastic demand affect total revenues of firms when they change the price. See you there. Hey, what's going on? I hope you liked this video and it helped clarify some of the stuff you're working on in your current economics studies. If you're looking for more resources to help you with AP Economics, IB Economics, intro-level university economics, economics teaching resources, one, go check out our website, Economics Videos That Don't Suck, evtds.com, for access to our entire catalog of economics videos, as well as practice questions, answers, and even entire mock exams. Two, be sure to subscribe to this channel, Economics Videos That Don't Suck, so you can get immediate access to all of our new videos as they're released, probably mirroring your economic studies right now.